Illustration shows a basketball player shooting a ball. Today, we are going to solve a problem from Fundamental of Physics Holiday and Resnick 9th edition about motion in two dimension, precisely projectile motion. At what initial speed must the basketball player in figure 450 throw the ball? At angle theta null equals 55 degrees above the horizontal to make the full shoot. The horizontal distances are d1 equals 1.0 feet and d2 equals 14 feet, and the heights are h1 equals 7.0 feet and h2 equals 10 feet. The problem is about motion in two dimension. The motion of the basketball is like the projectile motion, so we will analyze the motion using the equation for projectile motion. To make it easier to solve, we use the Cartesian coordinate system. We can write x-axis and y-axis. The ball shot an angle theta null with an initial speed v null. In the first step, we must identify the information given in the question and write it down given. The launch angle of the basketball theta null equals 55 degrees. The initial position of the basketball at x coordinate x null equals 0. The initial position of the basketball at y coordinate y null equals 0. This. The final position of the basketball at x coordinate x equals d2 minus d1. From this to this equals 14 feet minus 1.0 feet equals 13 feet. And the final position of the basketball at y coordinate y equals h2 minus h1. From this to this equals 10 feet minus 7.0 feet equals 3.0 feet. And the gravitational acceleration or g approximates 32 feet per square second. Then we identify what is being asked in the problem and write it down required. The initial speed of the basketball to make the full shot v null is solution. When the basketball player shoots the ball is launched by an angle and the motion of the ball is like projectile motion. First, we find the time in the air, t, using the equation for projectile motion. The final position in x direction equals this initial position in x direction plus the initial speed in x direction, the time, the acceleration in x direction, and the time. While in the horizontal direction or x direction, the moment the ball leaves the player hand, there's no forces, so there's no acceleration in the x direction. So we can write ax equals 0 and the initial speed in horizontal direction is V0 x equal V0 cos theta 0. This. And then we operate the equation, we get this, okay, then the t equation is this, then we substitute the value of each variable, okay, x 30 feet, x0 0 feet, and theta 0 is 55 degrees. So the equation for t is 13 feet divided by V0 cos 55 degrees. Then using the other projectile motions equation, this for vertical direction, we get the final position in vertical direction, the initial position, the initial speed in vertical direction, the time, the acceleration in vertical direction, the time. In the vertical direction, there's gravity, so there's acceleration due to gravity g. So we can write ay equals minus g. And the initial speed in y direction is V0 sin theta 0. Substitute this equation to this, then the equation becomes this. And then we substitute value of each variable, and we know that t equation is this. So we get this final position 3.0 feet, initial position 0 feet, V0 sin theta 0 55 degrees, and t using this minus a half g 32 feet per square second, and t is substituted this square. We operate this equation, okay, this and this, and then we get this, okay, this, okay, we get V0 square approx 2,704 feet cubic per square second divided by 5.148 feet. Okay, we get V0 square approx 525.3 feet square per square second, and V0 is root from this, so we get V0 approx 23 feet per second. And we can say that the initial speed of the basketball to make the full shoot is about 23 feet per second. That's all for today. I hope this is useful and see you in the next lesson.